In this lesson, we'll be taking a look at the special triangles, the 30, 60, 90 special triangle. I'll start off by explaining to you the 30, 60, 90 triangle. Then we'll use that information to derive the sine, cosine, and tangent of 30 degrees and 60 degrees in these triangles. And then we'll look at some examples together on how to apply the knowledge from these triangles. So the 30, 60, 90 triangle is formed from an equilateral triangle. An equilateral triangle is a triangle that has equal angles and equal sides. So if you look at the triangle ABC on the right hand side here, you can see that the angles are 60 degrees each. So that indicates that all the sides are going to be equal, which we indicate with this straight line cutting through the line. And we can see that when we draw an altitude from B to H, which an altitude always forms 90 degrees with the base here. And when we draw this altitude, we can see that we're dividing this 60-degree angle into two 30-degree angles. And so here we have a 30-degree angle, 60-degree, and then this is 90 degrees. So this is what we call the 30, 60, 90 triangle. So now, how do we use the 30, 60, 90 triangle to come up with the sine of 30 degrees and the cosine of 30 degrees? So what I'm going to do here is I'm going to draw the right triangle. If you notice here, we have two right triangles. They have the bases are equal, and they also share the same altitude, and they also have equal hypotenuses. So what we're going to do is we're going to try to draw out a right triangle. So this is our right triangle right here. And then we have here 30 degrees, and then we have 60 degrees here. And this is going to be 2. This is 1 because we're dividing 2 by 2, because this is going to be 1. This is going to be 1. Now we need to find, this is B, this is H, and this is C. So we need to find the value of BH. So we know Pythagorean theorem says that A squared plus B squared equal to C squared. So this is going to give me HC squared plus BH squared. These are lengths, so we're going to do this, equal to BC squared. All right, so let's go ahead. I'm going to just call this H just for clarity. So this is going to give me HC squared is 1 squared plus H squared equal to 2 squared. So this is going to be 1 plus H squared equal to 4. So let's go ahead and subtract 1. So H squared equal to 3. And here we're not interested in decimals. I'm going to leave all my answers in radicals. So H is going to be the square root of 3. So this is the square root of 3. So sine, remember from our SOHCAHTOA, so which means sine is equal to the opposite side to the angle divided by the hypotenuse. So now let's go and look at sine 30. Sine 30, this is going to give us opposite, which is 1, hypotenuse is 2. So sine 30 degrees is 2. What about sine 60, not cosine? We're going to be looking at sine 60 degrees. So sine 60 degrees, this is opposite, which is square root of 3, hypotenuse 2. So sine 30 is equal to 1/2. Sine 60 is the square root of 3 over 2. Now let's go ahead and start looking at cosine. We have a similar triangle, so since I've shown you how to come up with the sides, I won't do that again. So what we're going to have here is going to bring out this right triangle right here. We have square root of 3, we have 1, we have 2. This is 30 degrees right here, and then this is 60 degrees right here. And then we have CA, which is cosine, is the adjacent side to the angle divided by the hypotenuse. Okay, So with that in mind, let's find cosine 30 degrees. So this is adjacent, which is the square root of 3, divided by hypotenuse, which is 2. Cosine 60 degrees is going to give you adjacent, which is 1, hypotenuse, which is 2. So therefore, cosine 30 is the square root of 3 over 2. Cosine 60 is 1/2. And we can make some conclusions here that cosine 30 degrees is the same as sine 60 degrees, which is equal to the square root of 3 over 2. Likewise, cosine 60 degrees is going to be the same as sine 30 degrees, which is going to give us 1/2. Now let's go ahead and look at the tangent. How do we come up with the tangent? So let's do this for the tangent. So we have here square root of 3, we have 1, and then we have 2. So we need to find out tan, which is TOA, is tangent. This simply means that your tangent is the opposite side to the angle divided by the adjacent side to the angle. So let's look at here, we have 30 degrees, and then here we're going to have 60 degrees. So let's examine tan 30 degrees. Opposite is going to be 1, adjacent is square root of 3. Now in math, we don't like to leave irrational numbers in the denominator. It's not just a good practice. I mean, some people do, but for clarity, what we're going to do here is now we're going to rationalize this radical. So 1 over square root of 3 is going to be the same as, 1 over square root of 3 will multiply by square root of 3 divided by square root of 3. So this is going to give us square root of 3 over 3. So tan 30 degrees is square root of 3 over 3. What about tan 60 degrees? Tan 60 degrees is going to be opposite, which is square root of 3, adjacent is 1. So this is equal to square root of 3. So let's summarize this here. Tan 30 degrees is square root of 3 over 3. And then tan 60 degrees is equal to the square root of 3. So now we have this in mind, we're going to go ahead and use this information to solve some examples together. So if you have special triangles here, so if I see 60 degrees here, I know that I have 30 degrees here. So what we're trying to find is the value of GH. So we can use either one. So let's go ahead and try sine 30. Let's call this x right here. So sine 30, because we always start with looking at SOHCAHTOA. So now we need to ask ourselves, whenever you have the hypotenuse, you're going to be stuck with sine or cosine. So here I'm deciding we can use 60, and that's going to be cosine 60. And remember that they are the same, so it doesn't matter which one you use. So I'm going to just let's use cosine 60. Cosine 60 degrees is equal to opposite. No, cosine is, we're going to use cosine, is going to be adjacent divided by hypotenuse. So your adjacent here is x divided by your hypotenuse, which is 12. We also know that cosine 60 is 1/2 from what we had done earlier, is going to be x over 12. So you can do a cross product here. Let's go ahead with a cross product. So we have 2 multiplied by x equal to, it's actually not 12, it's 24. So 2 multiplied by x is equal to 24 multiplied by 1. So we're going to divide both sides by 2, and then x is equal to 12. So therefore, the length of GH is equal to 12. The next one we have here is we want to find out the length of HI. So we'll call this X. So we have we're looking for the opposite side to this angle, and we have the hypotenuse. Okay, so let's go with our SOHCAHTOA. We're looking for the opposite, and then we have hypotenuse. So whenever you have hypotenuse is one of these two, but because it's opposite, we're going to use the sine. So sine 60 degrees is equal to X over 24. And we know that sine 60 degrees, which is the same as the cosine of 30 degrees, is going to give you square root of 3 divided by 2. This is going to be X over 24. And so we're going to cross product now. And we have 2 multiplied by X is equal to the square root of 3 multiplied by 24. So let's go ahead and divide both sides by 2. So X is going to be the square root of 3 multiplied by 12. And we usually like to put the rational number to the left of the radical. So the whole number, the rational number to the left of the radical. So it's going to be 12 square root of 3. So X is going to be 12 square root of 3. And so therefore HI is 12 square root of 3. And then final example we have here is what is the length of GH? So we have X right here. We don't have a hypotenuse, but we'll go ahead and write our SOHCAHTOA. Here we don't have a hypotenuse, so we already know it's going to be tan. So tan, remember, is the opposite side to the angle, which is its opposite side divided by your adjacent side. So tan 60 is going to be opposite, which is 18 divided by X. We already know that tan 60 is the square root of 3, which is going to be 18 over X. So let's go ahead and cross product here. We have square root of 3 multiplied by X equal to 18 multiplied by 1. So we're going to divide both sides by the square root of 3. So we now have X is equal to 18 divided by the square root of 3. But we're going to go ahead and rationalize this radical. So 18 divided by square root of 3, we're going to multiply by the square root of 3 over the square root of 3, which is 18 square root of 3 divided by 3, which is going to give you 6 square root of 3. So therefore, GH here is going to be 6 square root of 3.